All right, so now we move on to lesson 7.1, which is the definition of what an absolute value is. Now, when we go into absolute values, this is going to help us define the rest of the unit in terms of when we talk about 7.1, 2, and 3, we need to understand what is an absolute value, what is it actually doing to any sort of input value, and then how does that reflect to the output value. Now, to break into this, we're going to look at this and say, well, for any real number that's x, the absolute value is always written with these vertical bars on the outside of the x, representing that it's always zero or a positive number. And that's something really important to note there, is that regardless of what number we put in there that's a real number, it's either going to be zero if it was just zero itself, or it's going to be some sort of positive value. Now, to give us a couple examples to go with this, let's say we take the absolute value 25. Well, an absolute value of a positive is just positive itself. Absolute of zero is just zero itself. And then if we get this negative situation, which is very, very important to note, so maybe I'll just kind of underline this here. If we end up getting a negative number, then what we end up getting is a positive number. Because again, when we talk about absolute values where there's these vertical bars on the outside of this, or on the outside of the input value, we consider everything to go to a positive value. Now, on your formula sheet, you're going to have the following absolute value form, which says that the absolute value of x is equal to the positive version of x if x is greater than or equal to 0, but then if it's less, we're going to consider it to be the negative variant, and you'll see what that means graphically. All that it typically means just verbally is that you're going to switch the slope. So if it was a positive slope for where x is a positive value, now if we take the other case of the absolute, it's where the x value is negative, and that occurs on the other half of the graph. Now, again, hold on to that in the back of your mind for now. We just know that this will appear on our formula sheet, and it will act as guidance for helping us define what a piecewise function is, because that's exactly what this is. All right, now absolute values can represent the distance from 0 on any given number line, and regardless of direction. So let's say we talked about the absolute value of -4. Well, this just represents that it's 4 digits to the left of 0. Now, do we care to put the negative in there? No, because all we're saying is that it's 4 units away from 0. So let's consider the example here. Let's say I have the absolute value of 4. Well, that means that there's two possible solutions here. Those two possible solutions are plus and minus 4. Because if x was either -4, which we could put a dot here, then its distance from 0 is 4 units. And then if we have a distance of +4 from 0, that means we're also 4 units. And so maybe what I'll do here is I'll just put a little bit of an underline indicating that we went from here to here, and I'll put little hashes on the outside too. I'll do the same thing from here to here. 4 to 0 is here and here. And this is 4 units away, so regardless of which direction, if I put in -4 or +4, the total distance from 0 is 4. Now, can x or the absolute value of x never be negative? Short answer is just no, because you can't have a -4 distance from 0 in terms of a description of just purely a number, right? Like when we say 4 units away from 0, yes, I guess you could go to the left or you could go -4 units, but what we want to consider this as, no, there's never going to be an outcome in which we have this written and it gives us this value of -4. So I'll never take the value, whether it's positive or negative, absolute x, and get a negative number. Now, in general, by definition, the absolute value of a real number of x is defined as the distance away from 0, or the units away from 0. Perfect. And then eventually we'll expand this definition and say, well, not only is it the distance slash units away from 0, but maybe it's the distance, the absolute distance between any 2 points, regardless of if they're 7 to -2 or whatever it might be. Now, let's consider the following. What if we were to compare and order certain absolute values? Well, how do we want to consider these? First and foremost, what I'd recommend is maybe put these all in decimal form, because if some of them are decimals, some of them are fractions. I mean, yes, you guys are all very good with fractions. Like at the grade 11 level, I typically don't see this being an issue, but if you're having a tough time visualizing these, what I would do is just write them in their decimal forms. So let's write it equals to, this is going to be the absolute of -0.75, which is 3/4. The absolute of a negative number just gives us the positive value itself. So that's technically the value of the first one. Now, for our next one, it's the absolute of 1.2, but there's a negative on the outside. And if the negative is on the outside, then what we have to do is just write it with the negative, because the negative isn't being considered in the absolute here. We now need to write this as this is equal to negative 1.2. Okay, the next one here, we're going to say this is equal to, well, 5 over 3, this is the same as 1.67 if we rounded it. So we can go absolute of negative 1.67. The absolute of any negative number just gives us the positive number, and there it is. And then with the absolute of 0.6, this is going to give us 0.6 because the negative number is, or the negative sign is included. And then lastly, we go to this one here, and it's the absolute of negative 2.1, which gives us 2.1 as a positive value. Now, when they say from least to greatest, let's just rank them, and we're going to put the original terms here. So our lowest value possible here is the absolute, and I'll put an L below it here. The lowest value is the negative 1.2. And remember, because that negative is not included in the absolute, it doesn't turn positive. It's only if it's directly within the absolute. Now what we're going to do is go to our next value. Well, we scan the row here and we see 0.6 is the next one. So absolute of negative 0.6. Put a vertical bar. Our next one would be, I believe, the 0.75, just looking at our list here. So we're going to go absolute of negative 3 over 4. Then we're going to go to our next one, which in this case is 1.67. So I'm going to put absolute of negative 1.67, or I'm going to actually put the original fraction, right? Because we want to put those original terms they gave us. So 5 over 3. And then lastly, we have the absolute of negative 2.1. There we go. Now, and I'll put a G here representing that this is the greatest. And then what I can do is even just put a line below representing that from left to right, we go from our least to greatest. Awesome. So just be very careful. If the negative's on the outside, then the number will stay negative. If the number's on the inside, it goes to a positive. And then any sort of, if we start mashing these up as fractions and decimals, maybe convert them all to decimals just so you can see it easily. Okay, now from here, let's look at like evaluating expressions just given certain algebra that's happening, or certain combinations of algebra that are happening within the absolute, and then we can simplify it to a following answer. Now, again, we're going to follow all the standard order of operations and then take the absolute values of these things. So you can almost think about it as these absolute value bars are almost considered to be brackets. So we want to do everything within the brackets. In this case, I'm going to simplify all the terms and keep the absolutes here. Absolute of 3 times negative 2 cubed is negative 8. And then this is going to be minus 15 because 5 times negative 3 minus 12, absolute value. This is going to be equal to the absolute of negative 24 minus 15 minus 21. There we go. We want to combine it all together. So I'm going to bring out the calculator to make sure we got all our values appropriately. So we take 24, we add it to 15, we add it to 21 because they're all negative. So we can just take that number and make it negative. In this situation, we get negative 60. And then because those absolute value bars are there, we're going to evaluate this to be positive 60. So there's our answer. All right. Now, let's say we look at part B. Part B is very similar, but we have a bunch of different absolutes. Let's evaluate all the inside of the absolute terms, and then we can start combining them together operationally after, because we got this negative, and then we got the positive, and then we got the division. What I don't want you to do is, do you see how there's a negative? I don't want you to distribute the negative. That's the wrong step. We don't want to do that. We want to make sure we evaluate the absolute for what it is and then combine the operations. So we're going to write this as, and maybe I'll combine a couple steps into one, 2 minus 6 squared. Well, that's 2 minus 36. This gives us negative 34 inside the first bracket. Absolute minus 7 minus minus 5. Well, we know a double negative is going to end up becoming positive. So this will end up becoming 7 plus 5, which is equal to positive 12, plus we're going to do our order of operations properly. Remember, we have to start with division, then go to our subtraction as the very last step. 16 divided by 2 is equal to 8. 8 minus the 8 that is a result of this will end up giving us 0. So absolute of 0. And then minus, again, we see this situation where it's a minus and a minus. Don't be like, oh, it's positive. We have to evaluate the inside first and do the absolute, then combine it. Don't think about these things in terms of being like a bracketed term. It's not negative and then the negative 1 needs to be distributed in. No, it's subtract the absolute value that we end up getting out of here. Think about it as a function. This is some sort of function happening. This is some sort of function happening. We don't want to just simply throw in a negative when we don't have to. Now, we're going to have the absolute of negative 2, which is just absolute of negative 2. Now I'm going to go below here and write all the absolutes. This is going to be 34 minus positive 12 because of the operation, plus 0, which is the absolute of 0, and then minus the absolute of negative 2, which is positive 2. 34 minus 12 is going to give us 22, minus another 2 is going to give us 20 for the value. So these should be your values here. And again, do not distribute into the brackets in terms of these signs. These signs need to hang out until you've done all the operations within the absolute and taken the actual absolute. You cannot just distribute the negative. If you do that, it's going to lead you or astray, and then you're going to be off and the value will be totally wrong. Okay, let's flip to our next page here. Now, if we're on a number line and we want to consider distance between two specific points, here's how we're going to do it. So let's say we're at A and C, right? A is -8, C is 0. Well, what I'm going to do is I'm going to always take the subtraction difference of those. So I'm going to say line segment AC is equal to the absolute distance between -8 minus 0. I'm always going to subtract the terms. Now, when I subtract the terms, it gives me the difference between these two terms. But again, I want to know the positive unit value. In this situation, it's the absolute of -8. Absolute of -8 is going to end up giving us +8 as the solution, and we're happy with this. Perfect. There we go. Okay, let's go between B and E. So if I look at B and E, well, B is at -3, E is at 8. Again, we're going to take the subtraction. It doesn't matter which order you do them in. I'm going to write it as B and E is equal to the absolute value of, let's say we start left to right, -3 minus, and I just want to get that value again, E is 8. This is going to end up giving us that B and E, or the line segment BE, the distance between them, is equal to -11 absolute value. Therefore, B and E is equal to 11 units different. Perfect. Okay, now that in terms of number lines, if it helps, just always read it left to right. And then again, the number one operation, regardless of which order, is you're always subtracting the numbers, because we want to think about it as we're getting the difference in distance between these two things. And then if it ends up being negative, well, good thing we have the absolute value bars, because it's going to force it to be positive. All right, let's look at some examples regarding around points and determining the distance, whether it be a horizontal or vertical line segment, or maybe even a slanted line like we're going to see in the last example. So if I look at this one here, well, I notice one thing in particular about these 2 points. The 9 that's here, this is representative of the y value, and the y value is the same. If the y value is the same, it means the 2 points are horizontal. It means I have this, where let's say I have my -12, and that point is going to be over here. This would give me the -12 and 9 here. On this side, it would give me the +4 and 9. And if we know these things are horizontal, then what we're actually doing is we're taking the difference between the x values to get the line segment distance. So we're going to call it AB is equal to the absolute value of -12, remember, minus the other term, which is 4. This is going to give me the absolute value of -12 minus 4 is -16. Absolute of -16 is going to be equal to +16 units. So the line segment of A and B is 16 units long. Okay, let's go over to part B. Now, same idea, we want to look at the points, and we're like, okay, if the x values are the same, this means we actually have a vertical line, and here's what the vertical line would look like. I would have one point maybe somewhere up here, one point down below, somewhere about here. Let's make sure we label these in. So I'm going to have my lower point, which is -5, -7 down here. I'm going to have my other point, which was -5 and +28, because it's higher on the y-axis. And then we're just going to take the difference in these two numbers in terms of their y values. P and Q is equal to the absolute value of, we can take them in either order. Maybe we do the negative first, -7 minus 28, because again, we want to subtract the 2 to get the overall distance. This is going to be equal to, well, -28 minus 7 is going to give us the -25. And if we end up getting, or not -25, but -35, and if we take the absolute value of -35, this is going to equal 35 units vertically that make up this line segment of P and Q. Okay, let's go down to part C. Part C involves just more of an arbitrary term, and it says if the y values are the same, and we end up wanting to figure out what the absolute value is, well, in this situation, because C and D involve like a B and an A, and we don't really know too much about them, all I know really is that the y values are the same, so the line segment would be horizontal, such as this, and then we would have maybe like A and Y on the left, and B and Y over here. If I want the absolute value of C and D, well, C and D, the line segment, is equal to, we're going to write it as A minus B, all absoluted. And then because we don't actually know these specific values, we're just going to leave it at this, because unless we knew what to plug in here and we had specific values, then we're not going to be able to actually evaluate the expression for anything more than just an A minus B. Okay, and I'm going to make sure I just highlight this because that's representing our arbitrary term. Lastly, if we have a slanted line, let's just plot it out like we were just doing some basic Cartesian. I'm going to recommend you just draw out some like very, very simple Cartesian where we have our x's and our y's. We're going to roughly plot these 2 points. So maybe let's put A down somewhere over in quadrant 3 because they're both negative. So -5 and -2, somewhere about here. And I'll make sure I plot that in, -5 and -2, because they're both negative, giving us the A value. We then can go to our quadrant 1 because they're both positive and go to like roughly about 3 and 4. So I'm going to write that here is B is 3 and 4. And then what we're going to do is just put a dotted line between these two, representing that the line segment connects these two. So we have here, 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 here. There we go. There's our line segment. And we know that this line segment is composed of 2 different sections. The first thing is the following. We have some sort of change in that x variable. We have some sort of change in the y variable, like this, that makes up this overall line segment. Now, in this situation, we want to figure out by Pythag, what are those 2 segments? So we have a hypotenuse, which we're going to call AB, and I should change that tool there. So this is going to be A and B. This is going to be our change in the x variable, represented up here. And I don't want to make this too condensed to the graph, so I'm going to make sure that I have it just nice and neatly put here. There we go, change in x. My change in y, or the change in vertical distance, is given here. Now, let's consider this logically. If we look at the change in the x and change in the y, the distance from A to B in terms of x is the absolute of -5 minus 3. So maybe we do that here. Let's write our change in x is equal to the absolute of -5 minus the 3 that was for the x of the other one. This gives us that the change in x is equal to the absolute of -8, which is +8. We're going to do the same thing for y. We're going to go change in y is equal to the absolute of -2, which is the lowest y value, minus the 4, because we always minus. Change in y is equal to -6 absolute, which is 6. Now what we can do is we can do our Pythag in order to get this hypotenuse value of A and B. We're going to go A and B is equal to, we have to take the 6 squared, and I should say AB squared, because right, it's our C squared plus 8 squared. Now what we're going to do is we're going to square root both sides. So I square root. Now I go like this. We're going to get AB is equal to, well, 6 squared is 36, 8 squared is 64, 36 and 64 gives us a square root of 100, and the square root of 100 is equal to 10. So therefore, our answer is going to be 10 for this. Our hypotenuse, our length between A and B, is simplified to be 10. Now, what I'm going to do is, just to make this a little bit neater, I'm just going to shuffle it up because I don't want it to blend too much into that next problem. There we go. Looks good to me now. Okay, now for our last problem here, what we're going to do is we're going to consider the following. And this is an application problem that gets us to consider, how do we consider absolute values when we're talking about things that are changing dynamically over a period. So on a stock market, individual stock and bonds fluctuate a great deal, especially when the markets are volatile. So lots going on, things are hitting the news, we have different companies making different moves, prices are going to change. Now, a trading stock on the Toronto Stock Exchange, the TSX, opened at the beginning of the month at $12.25 per share. It then dropped to $11.45, increased back to $13.05, and then finally closed the month at 12.70 or $12.70. Determine the total change in the stock over this month, and then this total is going to represent the active stock for the month, or how active it was. And then we want to sketch a graph to roughly estimate what's happening here. So let's just say I want you to draw a very basic quadrant 1 here, where we're going to have our dollar figures on the y-axis, and we're going to have our, maybe let's say our time or our time period on the x-axis. So our first value started at 12.25. So what I'm going to do is, because there was a sequence of 4 events, I'm going to go 1, 2, 3, 4. And we could assume this as each tick is a week that goes by. So maybe we say like first week there was a price, second week there was a price, third week, fourth week, until we close the month, right? Now, I'm going to put a sequence of dots and label those points. If we started at 12.25, I'm just going to approximate that 12.25 is roughly about here. And then I'm just going to make sure that I label this point here. So I'm going to go 12.25. Perfect. Okay. Now, our next point here was at 11.45. So we're going to go a little bit lower. We're going to go somewhere about here. We don't want to go really low. We just want to go enough that we see some sort of decrease. And again, we're going to write this in. So this was going to be at 1145. Perfect. Our next point from here is said that it spiked up to 1305. So this is going to be our highest value of all three. It's going to be roughly about here. So 1305. There we go. And then we're going to go down to 1270 where it closes the month. So it's kind of between those the first and third points here. There we go. So we got 1 point, 2 point, 3 point, 4 point, and we want to make sure we label this as the end of month value, 1270. Okay, now what I'm going to have you do is I'm going to have you connect these with a dotted line. So I'm just going to have you go like this. So it's moving, it's going along this trend, it increases, and then it decreases back down. Now, in order to figure out the total volatility or how much it changed overall during the month, what we want to do is we want to figure out the individual sections of plus and minus in terms of how far did it go up, how far did it go down, and then we want to sum them all together. Here's what I recommend when you get a problem like this. Every 2 points, so let's say it's your first to second point, put a 1. Your second to third point, put a 2, representing that this is the second thing that happens. So I'm going to go number 2. And then between the third and fourth point, I want you to write a 3, representing that this is the third thing that happens. Now, to get the overall fluctuation or to get the overall dollar figure that happens during the month, the activity is going to be described using the following. We're going to take each of these segments and add them together. So I'm going to say the volatility is equal to, now we're going to put the following absolute values together. We're going to always read it left to right. So I'm going to go 1225 minus the 1145. Absolute bar, plus we're going to do the next segment. The next segment is 1145 minus 1305. And then we're going to add our final segment, which was 1305 minus 1270. And what I'm going to recommend is, again, we're always subtracting these in this situation, but along with subtracting them, always read it left to right. Now we're going to go volatility is equal to, or the total change in the stock is equal to, and then we're going to make sure that we have our, and let's make sure we just ignore this here. Perfect. There we go. And I'm going to make sure I correct the spelling for these. That's probably why it's giving me the warning here. There we go. Perfect. Okay, now from here, let's do our calculations here. So we're going to take the differences in these, and I'll bring open my calculator here so we can do the total. And in your calculators, what you can actually do is you can do math absolutes. So if you go math and then scroll 1 to your right, you'll be able to get this absolute value bars. In the CAS it's a little different, so I can help you. But in the TI specifically, we can go our math and then scroll 1 over to the number. When we're in number in the category, the ABS or absolute is a way of getting these absolute value bars. You can type this all in and you can be like, well, 1225 minus 11.45. Go outside of the bracket, go plus, or not the bracket, but the absolute bar. Do our math absolute again. So we're going to repeat that process. I'm going to go 1145 minus 1305. There we go. And then one more time, we go math, number, ABS or absolute, 1305 minus 12.70 or $12.70. Enter. This is our total fluctuation, is $2.75. So the overall volatility during the month is $12.75 per share. And again, this isn't saying that it's like, oh, it's increasing and decreasing by 1275 in these different periods. What this is referring to is that during this time window, over this course of this whole month, the overall action, whether it be positive or negative in terms of change, is going to be a total of $2.75 per share. So not bad. And in fact, in this situation, they actually made a little bit of money. So if they ever asked you, they said, hey, did they make or lose money? Well, you know, because the original was $12.25. The new value was $12.70. Yes, they did make up a bit of that margin, but that's not what they asked for. They said, what was this overall activity during the course of this month per share? All right, here's where you're going to want to go into your assignment and just make sure that you do a couple of these practice problems just to get the idea of doing absolute values and realizing that the absolute is the total distance between any 2 points. And it's not a measure of being negative or directly positive. It's the overall unit measure, the absolute measure between any 2 points. All right, good luck with your practice.